we're asked to write out all the functions f that map the set with elements 1, 2, and 3 to the set with elements a and b in two-line notation, where the set with elements 1, 2, and 3 is the domain, and the set with elements a and b is the codomain. Because there are 3 inputs, and each input has 2 possible outputs, 2 times 2 times 2 is equal to 8, there are 8 possible functions. Let's label the functions f sub 1 through f sub 8. Each of the functions has 1, 2, and 3 as inputs, which go in the first row of the matrix for two-line notation. And now to determine the outputs. The outputs come from the codomain, which is a set with elements a and b. For function 1, let's let all 3 outputs be a, meaning 1 maps to a, 2 maps to a, and 3 maps to a. For function 2, let's let all the outputs be b, meaning 1 maps to b, 2 maps to b, and 3 maps to b. For function 3, let's let 1 output be a and 2 outputs be b. Let's let 1 map to a, 2 map to b, and 3 map to b. Then let's let 1 map to b, 2 map to a, and 3 map to b. And then let's let 1 map to b, 2 map to b, and 3 map to a. And now let's let the outputs be 2 a's and a b. Let's let 1 map to a, 2 map to a, and 3 map to b. Then let's let 1 map to b, 2 map to a, and 3 map to a. And let's also let 1 map to a, 2 map to b, and 3 map to a. And now we have all the possible functions. So for number 1, how many functions are there? There are 8. Again, there are 8 because there are 3 inputs, and for each input there are 2 possible outputs. 2 times 2 times 2 equals 8. Number 2, how many of the functions are injective? A function is injective provided every element of the codomain is the image of at most one element from the domain. In order for a function to be injective, none of the elements from the codomain can be repeated as outputs. And notice in all these functions, at least one of the elements from the codomain is repeated as an output. Or more specifically, f sub 1 and f sub 2 are not injective because the output value from the codomain is an image of 3 elements from the domain, and for functions f sub 3 through f sub 8, in each case, one of the outputs is an image of 2 of the elements from the domain, and therefore none of the functions satisfy the definition that every element of the codomain is the image of at most one element from the domain. And therefore number 2 is 0. Number 3, how many are surjective? A function is surjective provided every element of the codomain is an image of at least one element from the domain. Well, functions f sub 1 and f sub 2 are not surjective because for function f sub 1, the element of b from the codomain is not an image of at least one element from the domain, and for function f sub 2, the element of a from the codomain, again, is not an image of at least one element from the domain. However, functions f sub 3 through f sub 8 are surjective, again because in each case, the elements of a and b from the codomain are images of at least one element from the domain. In some cases, it's an image of 1. In other cases, it's an image of 2 elements from the domain. So there are 6 surjective functions. So if there are 8 total functions, 0 injective functions, and 6 surjective functions, that means 2 of the functions are neither injective nor surjective, and that would be functions f sub 1 and f sub 2. These 2 functions are not injective and also not surjective. And number 4, how many are bijective? Bijective functions are both injective and surjective, and because there are 0 injective functions, there must be 0 bijective functions. In order for a function to be bijective, to begin with, the number of elements in the domain and codomain must be the same. I hope you found this helpful.